Hi everyone, welcome back. In this video, we are going to discuss top DevOps interview questions and answers. Let's begin. What is DevOps and why is it important? DevOps is a software engineering culture and set of practices that integrates development and operations teams to deliver software faster, more reliably, and with higher quality. Traditionally, development teams wrote code and handed it over to operations for deployment, often leading to delays, miscommunication, and production issues. DevOps removes these silos by encouraging collaboration, automation, shared responsibility, and continuous improvement. DevOps is important because modern applications require frequent updates, quick fixes, and consistent performance across environments. Companies today cannot wait weeks or months to deliver new features. DevOps automates processes like building, testing, deployment, monitoring, and infrastructure provisioning, which drastically reduces manual effort and human errors. With DevOps, organizations achieve faster time to market, more stable releases, scalable infrastructure, and improved customer satisfaction. It directly supports agile development, cloud computing, microservices, and continuous delivery models. In interviews, emphasize DevOps as a combination of culture, process, and tools, not just tooling alone. Next, what are the key stages of a DevOps lifecycle? A typical DevOps lifecycle consists of several continuous stages designed to deliver software efficiently and reliably. The lifecycle begins with planning, where teams define requirements and break work into iterations. This moves into coding, where developers write and version control their changes using systems like Git. The next stage is building, where the code is compiled, dependencies are resolved, and artifacts are generated using tools like Maven, Gradle, or NPM. Next is continuous integration, where automated tests verify code quality and detect issues early. After CI, the continuous delivery or deployment stage pushes the code to staging or production through automated pipelines. Once deployed, the application enters monitoring, where logs, metrics, and performance data are analyzed to ensure reliability. The final stage is feedback, allowing teams to learn from metrics, incidents, and user behavior and make improvements. These stages repeat continuously, creating a cycle of constant improvement and rapid delivery. Next question: what is CI/CD and how does it improve software delivery? CI/CD stands for Continuous Integration and Continuous Delivery or Deployment. Continuous integration means developers frequently push small code changes to a shared repository where automated tests validate the code. This prevents integration issues, reduces bugs, and ensures the codebase stays healthy. Continuous delivery extends CI by automatically preparing every valid build for release. The software is always in a deployable state, but deployment is done manually. Continuous deployment goes one step further and pushes code to production automatically whenever it passes all pipeline stages. CI/CD improves software delivery by speeding up releases, reducing manual work, catching bugs early, and creating predictable pipelines. It supports agile and microservices architectures by ensuring each service can be built, tested, and released independently. In interviews, emphasize that CI/CD reduces risk, increases developer productivity, and supports rapid iteration. Next, what is infrastructure as code, IAC? Why is it used? Infrastructure as code is the practice of managing and provisioning infrastructure using code instead of manual processes. Instead of clicking buttons in a cloud console, you define your servers, networks, load balancers, and configurations using code files. Tools like Terraform, AWS CloudFormation, and Ansible implement IAC. Infrastructure as code is used because manual infrastructure management is slow, error-prone, and not scalable. With IAQ, you can recreate entire environments consistently, version control the infrastructure, automate deployments, roll back easily, and maintain predictable, stable systems. IAC supports DevOps principles by enabling repeatability, automation, and transparency across development and operations teams. It also enables immutable infrastructure where servers are replaced, not manually updated, greatly reducing configuration drift. Interview tip: highlight consistency, scalability, reproducibility, and automation as key benefits. Next question: what is containerization and how is it different from virtualization? Containerization packages an application and its dependencies into lightweight, isolated units called containers. Unlike virtual machines, containers share the host OS kernel, making them far more lightweight, fast, and efficient. Docker is the most popular container platform. In virtualization, each VM contains a full operating system, which consumes heavy CPU, RAM, and storage. Containers, however, run on a shared OS and isolate only the process environment, making them extremely fast to start and stop. Containerization improves DevOps workflows because applications behave consistently across development, testing, and production. They are also ideal for microservices, where each service runs independently in its own container. In interviews, emphasize portability, lightweight execution, and rapid scaling as key advantages. Next, what is Docker and why is it popular in DevOps? Docker is a platform that allows you to build, package, and run applications inside containers. It standardizes environments by ensuring that the application runs the same everywhere, whether on a developer's laptop or a production cluster. Docker is popular because it simplifies deployment, eliminates dependency issues, improves resource utilization, and integrates seamlessly with CI/CD pipelines. Docker also supports orchestration with Kubernetes, making it easy to scale and manage large containerized applications. Interview tip: mention Docker file, images, containers, registries like Docker Hub, and how Docker supports microservices architecture. Next question: what is Kubernetes and why do companies use it? Kubernetes is an open source container orchestration platform that automates deployment, scaling, load balancing, and management of containerized applications. Companies use Kubernetes because managing containers manually becomes extremely difficult as applications grow. Kubernetes automatically handles container scheduling, restarts crashed containers, distributes traffic, scales up/down based on load, and rolls out updates without downtime. It abstracts infrastructure so applications run consistently across cloud providers like AWS, Azure, and Google Cloud. In interviews, emphasize that Kubernetes is essential for microservices, architectures, and modern cloud-native applications due to its reliability, self-healing, and automation capabilities. Next, what is configuration management? Why is it important in DevOps? Configuration management, CM, is the practice of maintaining consistent configuration of servers, environments, and software throughout the application lifecycle. It ensures that all systems run the expected configurations and behave predictably across development, testing, staging, and production. Tools like Ansible, Chef, Puppet, and SaltStack automate configuration tasks such as installing dependencies, managing files, setting environment variables, and applying security policies. CM is important in DevOps because manual configuration leads to errors, inconsistencies, and "it works on my machine" problems. With CM, every environment is reproducible and version controlled, making rollbacks and disaster recovery much easier. It also reduces downtime, increases deployment speed, and ensures systems remain compliant with organizational standards. in interviews highlight that CM plays a vital role in automation, repeatability, and infrastructure stability. Next question, what is continuous monitoring in DevOps? Continuous monitoring is a DevOps practice that focuses on observing the performance, health, and reliability of applications and infrastructure in real time. Monitoring tools like Prometheus, Grafana, ELK Stack, Datadog, and New Relic collect metrics, logs, events, and traces to detect performance issues, security threats, and system failures early. It ensures teams have visibility into application latency, CPU usage, memory consumption, database response times, user activity, and errors. Continuous monitoring is important because modern applications are distributed across multiple microservices, containers, and cloud platforms. Without monitoring, failures may go unnoticed until users complain. In interviews emphasize that monitoring closes the feedback loop and provides data for continuous improvement. Next, what is Git and why is it essential in DevOps? Git is a distributed version control system used for tracking changes in source code. It allows developers to collaborate, maintain code history, create branches, merge work, and manage releases. Git is essential in DevOps because CI/CD pipelines depend on version control systems to detect new changes, trigger builds, run tests, and deploy updates. Git also enables parallel development using branching strategies like Git flow, trunk-based development, and feature branching. Its distributed nature allows every developer to work offline with a full repository copy, improving resilience and speed. Platforms like GitHub, GitLab, and Bitbucket provide additional collaboration features like pull requests, code reviews, and issue tracking, which strengthen DevOps culture. Interview tip: mention commits, branches, merging, pull requests, and conflict resolution. Next, what is GitOps? How is it different from DevOps? GitOps is a modern operational model that uses Git as the single source of truth for infrastructure and application deployment. Instead of manually deploying apps or modifying cluster configurations, everything is defined as code and stored in Git. Automated controllers like Argo CD or Flux continuously ensure the actual system state matches the desired configuration stored in Git. GitOps differs from DevOps in that DevOps is a broad culture and practice, while GitOps is a specific implementation of infrastructure and deployment management that relies exclusively on Git workflows. GitOps improves auditability, rollback capabilities, and security. Any change to infrastructure must go through Git review processes, ensuring full visibility. Next question. What is Jenkins and how is it used in DevOps pipelines? Jenkins is an open source automation server widely used to build CI/CD pipelines. It automates tasks such as compiling code, running tests, generating artifacts, scanning vulnerabilities, and deploying applications. Jenkins uses jobs and pipelines written in Jenkins file using Groovy to define each stage of the software lifecycle. It integrates with tools like Git, Maven, Docker, Kubernetes, SonarQube, and cloud providers. It offers plugins that extend capabilities for testing, notifications, releases, monitoring, and deployment. Because Jenkins supports distributed builds, teams can scale build tasks efficiently. In interviews emphasize that Jenkins remains one of the most flexible CI/CD tools, although GitHub Actions, GitLab CI, and Circle CI are modern alternatives. Next question. What is artifact repository management? Artifact repository management refers to storing, versioning, and distributing build artifacts such as JARS, WARS, Docker images, NPM packages, Python wheels, and configuration bundles. Tools like Nexus, Artifactory, and AWS ECR serve as central locations where CI/CD pipelines publish build outputs. These repositories also act as caches for remote dependencies, reducing build time and ensuring consistency across environments. Artifact management is crucial for large teams because it controls how software packages flow from build to production, enforces versioning, and enables reproducible deployments. In interviews mention that artifacts are immutable, traceable, and form a key part of modern DevOps workflows. Next question. What is the difference between continuous delivery and continuous deployment? Continuous delivery ensures that every code change is automatically tested and prepared for release, but deployment to production still requires manual approval. Continuous deployment goes further by automatically deploying every successful build to production without manual intervention. In continuous delivery, the pipeline stops before releasing and waits for human verification. In continuous deployment, the process is fully automated and relies heavily on strong test suites, monitoring setups, and safe deployment techniques like Canary releases and blue-green deployments. Both aim to reduce manual effort, improve confidence in releases, and shorten delivery cycles, but continuous deployment requires more maturity, automation, and safety mechanisms. What is infrastructure as code, ISC, and what problem does it solve? Infrastructure as code, IAC, is the practice of managing infrastructure, servers, networks, load balancers, databases, using code rather than manual processes. Instead of clicking in cloud consoles or running ad hoc scripts, you define your infrastructure in configuration files written in tools like Terraform, CloudFormation, Pulumi, or Ansible. IAC solves the biggest problem in traditional IT operations. Manual configuration is slow, error-prone, and impossible to reproduce perfectly. With IAC, every environment, dev, QA, staging, and production can be created identically from the same configuration. It also brings version control, auditability, and rollback capabilities. If something breaks, you simply revert to a previous commit. IAC promotes automation, reduces human error, speeds up deployments, and supports immutable infrastructure where instead of modifying servers, you recreate them from code. In interviews, highlight reproducibility, consistency, scalability, speed, and the ability to treat infrastructure like software. Next, what is container orchestration and why is Kubernetes so widely used? Container orchestration automates the deployment, scaling, networking, and lifecycle management of containers. In microservices architectures, applications run across hundreds of containers, making manual management impossible. Orchestration platforms like Kubernetes handle scheduling, health checks, auto-scaling, load balancing, self-healing, and rolling updates. Kubernetes is widely used because it is cloud agnostic, open source, and backed by the CNCF ecosystem. It supports declarative configuration, meaning you describe your desired state, and Kubernetes continuously ensures reality matches it. Kubernetes also provides built-in service discovery, secrets management, configuration injection, ingress routing, and persistent storage capabilities. In interviews, emphasize that Kubernetes enables teams to manage distributed systems reliably, reduce downtime, and scale applications automatically. DevOps and cloud-native development depend heavily on Kubernetes. Next, what is a blue-green deployment? How does it reduce downtime? Blue-green deployment is a deployment strategy that uses two identical environments: blue, current production, and green, new version. The new version of the application is fully deployed and tested in the green environment, while blue continues serving users. When everything in green is verified, traffic is shifted from blue to green instantly, often using load balancers or routing rules. This approach drastically reduces downtime because the actual switch happens in seconds. It also allows instant rollback. If something fails in green, traffic can be redirected back to blue. Blue-green deployment is heavily used in microservices, Kubernetes and cloud platforms because it supports zero downtime updates and eliminates risk associated with production deployments. Mentioned during interviews that it provides safety, fast rollbacks, and predictable releases. Next, what is a Canary deployment and when is it preferred over blue-green? A Canary deployment gradually releases a new version of the application to a small percentage of users first, like 1% or 5%. Based on performance, metrics, and user behavior, traffic is then slowly increased until the new version serves everyone. It is preferred over blue-green when risk needs to be minimized. Instead of exposing all users at once, Canary ensures any issues, memory leaks, latency, failures appear early in a small sample. Canary deployments rely heavily on monitoring tools like Prometheus, Grafana, Datadog, and SLO-based alerts to automatically roll back if metrics degrade. In interviews, emphasize controlled rollout, real user testing, automated rollback, and safety for large-scale production systems. Next, what is chaos engineering in DevOps? Chaos engineering is the practice of intentionally injecting failures into systems to test their resilience and recovery capabilities. Instead of waiting for real outages, teams simulate failures such as shutting down servers, dropping network packets, increasing latency, killing containers, or failing databases. The goal is to discover weaknesses before they affect customers. Tools like Netflix Chaos Monkey, Gremlin, and AWS Fault Injection Simulator allow controlled experiments. Chaos engineering helps teams validate autoscaling, failover mechanisms, load balancing, and disaster recovery strategies. It also improves confidence in distributed systems running across cloud, Kubernetes, and microservices. In interviews, highlight that chaos engineering is proactive reliability engineering. Break things intentionally to build stronger systems.